Hello, everyone. Welcome back. Today we're going to do a review about common factoring. So, what is common factoring? Well, common factoring is probably the only kind of factoring we know how to do before grade 10, unless we're vastly ahead of everybody else. But basically, common factoring is when we look at the terms we have and we remove the greatest common factor from them. Okay, so to common factor, we first have to ask ourselves what's the greatest common factor, or the GCF, of all of our terms that all of them have in common. And then we divide by that term in order to factor. So let's give an example here. Here we have 10x squared minus 15x. Well, first we have to ask what's the GCF, the greatest common factor of 10 and 15? Well, that's going to be 5, right? That's going to be 5. And then we also have our variables, x squared and x. Well, what's the greatest common factor of x squared and x? Well, clearly just the 1x, right? So we know that the greatest common factor of 10x squared and negative 15x is 5x. And now we're going to divide each term by 5x to find out what's in the brackets here. So what's 10x squared divided by 5x? Well, that will be 2x. And then what's negative 15x divided by 5x? Well, that would be negative 3. And so this is the factored form of the above. Okay. And something I want to be very clear about with factoring, we're not actually changing the equation, we're changing the form of the equation. So this equation looks different from this equation, but in terms of their meaning, they're the same thing, right? If I were to graph these two equations on a graphing calculator, and you can try this, it will show you the exact same graph, because in terms of what these two things mean, they mean the same thing, right? And that's on purpose, because our goal with factoring isn't to change the equation. The goal is just to change the form of the equation. Now, you might ask, well, what's the point of factoring then if it doesn't actually really do anything? Well, we'll get into that later, but long story short, if we want to solve something, oftentimes it can be easier to solve using factored form, and so knowing all the different ways of how to factor something can help us to solve it later on. And so that's the purpose of factoring in that context. Okay, let's try this next one here, number 2. Here we have 8x squared y minus 22xy squared. Well, first of all, what's the greatest common factor of 8 and 22? Well, let's see. It can't be 8, can't be 4, because 4 doesn't go into 22, but it can be 2. So I'm going to write down 2. Okay, now what's the greatest common factor of x squared and x? Well, just x. And then what's the greatest common factor of y and y squared? Well, that would just be y. Okay, so now what is 8x squared y divided by 2xy? Well, that will be 4x. And then what's negative 22xy squared divided by 2xy? Well, that's going to be 11y. And there we go. Right, so same thing here. These two equations, they are the exact same in terms of their meaning, but they're in a different form, right? One is just in a standard form, one is factored. Okay, in this next example, we actually have 3 things that we're going to need to take into account. So we need to know what's the greatest common factor of 6, 15, and 18. Okay, well, let's start with 6. Could 6 be the answer? Well, no, because 6 is not one of the factors of 15, so that can't be it. Okay, what about 3? 3 is the next biggest for 6. Well, yes, 3 will work. 3 is a factor of 6, 15, and 18, so it must be 3 then. So I'm going to write that down, 3. Okay, and what's the greatest common factor amongst x squared, x cubed, and x? Well, have to be x. And then what's the greatest common factor among y squared, y to the power of 4, and y cubed? Well, y squared. Okay, and then now what's 6x squared y squared divided by 3xy? Well, that would be 2x. Okay, and then what's negative 15 x cubed y to the power of 4 divided by 3xy squared. That would be minus 5x squared y squared. And then last but not least, what is 18xy cubed divided by 3xy squared? Well, let's see, 18 divided by 3 is 6, x divided by x is just 1, and then y cubed divided by y squared, that's y. And so there's our answer. There's our final answer there. Awesome. All right, let's try two more here. So this next one has for coefficients 4, 8, and 14. So what's our greatest common factor? Well, the greatest thing it possibly could be would be 4, right? So is 4 going to work? Well, no. 4 works for 8, but 4 is not a factor of 14, so that's going to be a no. Okay, how about 2? Right? 2 is the next greatest factor of 4. Is that going to work for 8 and 14? Yes, it is. So it is their greatest common factor. So I'm just going to put 2 here. Okay, and then you'll notice here that we actually can't common factor anything else out here other than the 2, right? Because you'll notice the second term here, it doesn't have an x in it, so we can't factor out even a single x, let alone an x squared or an x cubed. And then same with y, right? Not all the terms have even a single y in them. This first term doesn't have a y for us to factor out, so we can actually only factor a 2 out of here because not all the terms have an x and not all the terms have a y. These two terms have an x, right? Or sorry, a y, and these two terms have an x, but not all three of them have the same variable, so we can't actually factor out a variable here. So we can only factor out a 2. Okay, so what's 4x divided by 2? Well, that's 2x. What's 8y divided by 2? That's 4y, or in this case, I should say negative 8x, or 8y divided by 2 is negative 4y. And then what is 14xy divided by 2? That would be 7xy. And there we go. Awesome. All right, and let's move on to number 5. Okay, so first of all, what's the greatest common factor between 5 and 2? Well, the greatest common factor between 5 and 2, truth be told, is 1, right? Because the factors of 5 are just 1 and 5. The factors of 2 are just 1 and 2. Or same with negative 2, just negative 1, negative 2, 1, 2, right? And so the greatest common factor here is 1, and so we can't actually factor anything out other than a 1, and factoring out a 1 doesn't actually change the format of this at all. So we actually don't have to include that at all. You'll also notice that this term has an x in it, right? But this term doesn't, so we can't factor out an x. However, both the terms have a y, so that's we can factor out. We can factor out a y. So then if we do that, we get this as our final answer. And something I want to add too is it's not always possible to common factor. Let's say that the greatest common factor of something is just 1. Well, then you're good. Then you may be asked to factor. If I gave you question 6, a trick question, and said 5xyz plus 3abc, and I said, I want you to common factor this. Well, there's no way to common factor this because if we look at the common factors, the greatest common factor of 5 and 3, well, that's just 1. And then none of the variables are repeating, right? There's quite literally nothing we can actually factor out of here. And so, you could argue that either this is already the factored form or that there is no factored form because we can't possibly factor this at all. It's completely unfactorable. Okay, and we'll talk more about different cases where we can and can't factor in certain ways. This is an example where we can't factor in any way, right? But but there are other ways we can factor other than just looking for greatest common factor. This whole lesson is about common factoring and how to common factor. But in future lessons, I'm going to go over all the different ways there are of factoring. And if none of them are working, then what you're looking at, either you haven't learned the factoring method yet, or it is not factorable, right? Because not everything is always factorable. And in fact, sometimes you will get quadratics that are not factorable. We'll talk more about that later and how to tell whether something is or isn't factorable in the future moving forward. But for now, all you've got to remember for common factoring is to find the greatest common factor and then divide each term by that greatest common factor in order to fully factor, or not fully factor, but to factor to factor as far as we know how to factor at least. So there we go. All right, well, good work, everyone, and I will see everyone next day. Bye, everyone.